This is CIT 1122, Module 6, Submodule 1, Ether Channel. Ether Channel, in this particular section, we're going to go through two parts. There's the Ether Channel operation, which we'll cover in this piece, and then the Ether Channel configuration, which we'll show in the next piece. Ether Channel, one of the easiest technologies that we're going to cover through these courses. Really straightforward. Ether channel means that we are going to take what would be a looped transmission between two switches, and we are going to tie them together and create a single path with twice the bandwidth. So we can expand our bandwidth based on the number of cables that we connect in between these devices. So this slide actually, I think, does a really good job. I mean, it's kind of a simplistic deal, but you know, you've got two cables going between these switches, and then there's a nice little circle that shows you, hey, you know, we're tying these together. This is Ether channel. So you can put as many as 8 interfaces on two different switches together, and that would multiply the bandwidth between the two devices by 8 times. So there's no loss in adding Ether channel. It's not like, hey, I've got 2 gigabit Ethernet interfaces and connecting to 2 gigabit Ethernet interfaces. How much bandwidth do you get in Ether channel? You get 2 gig. It doesn't. You know, oh well, you know, when you tie them together, you lose something. You don't lose anything. You don't lose anything. So that's where Ether channel's at. It's a cool concept. You'll see it on desktops as well. Sometimes you'll hear people talking about something called NIC teaming on servers, where you'll tie network cards together to increase the bandwidth on those cards. And it's the same concept and idea. So we're going to make virtual MAC addresses, and we're going to make big connections between devices because we're going to add a lot of wires. And sometimes, you know, this is the best method that you need. You have a link between a couple of devices, and it's just getting saturated with data, and you're buffering and you're losing packets and things aren't working the way you should. Ether channel could be the solution to that. The other thing Ether channel is going to do is it's going to keep you out of a single point of failure. So if we Ether channel together two cables between two switches, and one of those 4 interfaces, one of them fails, one of those links is going to go down, the other one's going to continue to work. So that's something that you have too. So you do get some fault tolerance out of that. There are 2 different kinds of Ether channel. One is called PAGP, and the other one's called LACP. PAGP is the Cisco proprietary Ether channel protocol. These have got to be Cisco switches in order for this to happen. In this chapter, we're going to show you how to configure both PAGP and LACP. So you get to see them both. And this just shows you here the different settings that you can set. And the settings that you have for PAGP are auto and desirable. So there's always on as well. On is great. But auto and desirable will identify what mode that you're in. And you can see all the combinations of auto and desirable there. If they're both set to desirable, is it going to create an Ether channel? Yes. If one side is desirable and one side is set as auto, will it create an Ether channel? Yes. If they're both set as auto, will it create an Ether channel? And the answer is no. The answer is no. So don't set it auto on both sides, because that will not create what you're looking for. Now, if we look at LACP, the LACP settings are slightly different. Instead of what we just saw, we now have active and passive are our keywords. And this is how you're going to tell the difference when you make your channel groups as to which one you're using. So if you're going to use active and passive, then you know you're creating a LACP port channel group. Okay? So keep that in mind. We might as well just keep going for configuring Ether channel and take a look at these slides. As far as it goes, you know, when you're setting up interfaces, they have to be at the same speed. They have to be in full duplex, or they have to be in the same duplex mode. It seems insane to set up Ether channel with half duplex, but you know, that's up to you. The VLANs that are going to cross this, in most cases, Ether channel is going to be between switches, switch to switch. Those are going to have VLANs. Those are going to be trunk ports. And almost every time I've set up LACP, it's been between switch to switch. So keep that in mind. The VLANs do have to match. If there's a range of VLANs, they have to match as well. No big deal there. And that takes us to our configuration examples here. So if you look over on the left, you got your PAGP configuration, and you look on your right, you've got your LACP configuration. In both cases, what you're going to start off with is an interface range. So in these cases, you've got a couple of interfaces that you want to have created a channel group. So on the left-hand side for PAGP, interface range, FA0/3 to 4. On LACP, they're going to use interfaces 1 and 2, no big deal. Then they differ a little bit. You'll take that range and you'll make a channel group out of it, and you'll set it to either auto or desirable or on for PAGP. So channel group, and then pick a number, mode, desirable, great, and then do a no-shut on it, and it's squared up. Then once the channel group is created, you're going to go into that interface and you're going to set trunking on that port channel. So interface port channel 1, switch port mode trunk, switch port trunk native VLAN 99. Great. The second part of that is just the other side of that link. One thing I do want to point out is this, is that on the left-hand side for this PAGP, you notice the port channel number is 1, and that is going to go back to this value here. And then when the other side of those cables are connected, wherever those cables are connected on S3, in this case, in interfaces F0, 3, and 4, also, they also have to use the number 1. So if I set up a cable, and on one side I use port channel 1, and on the other side I use port channel 2, it absolutely will not work. You need to have the same port channel number for both sides. On the LACP side, interface range, great. Set the trunking right then and there, that's okay. And both of these are trunking commands, that's fine. Then name the channel group, so channel group 2 mode, set it as active, that's the whole thing. No shut it, boom, you're in business. So it's a little bit more efficient to do LACP than it is to do PAGP. In my experience, we did LACP on a regular basis, PAGP never. But that's just, it just depends on what shops that you work in as to which Ether channel solution may or may not be used. The other thing you can always do too is if you're running out of bandwidth for whatever reason, check your spanning tree. Make sure that the traffic is passing across the fewest number of switches possible when you're making connections between devices. And the other thing is, fiber optic cable is so inexpensive now, and the SPF connectors are so cheap that a lot of times it just makes sense to buy a switch that's got some fiber optic connectors, and you can go. Those will go at 1 and 10 gig, and they don't break the bank anymore. So you can always move to something like that if you find you're rolling low on bandwidth. The other option is this, and it does work. So sometimes if you're in a pinch and you just need another 1,000 megs across a trunk link, this is a good way to get it done. Great.